Hello and welcome back. In today's video, we will dive into building classification model using support vector machine algorithm. If you missed our previous video where we explored k-nearest neighbors algorithm, please be sure to check it out. For this tutorial, we will be working with the iris dataset. Okay, so I'll leave the link down below. You can click on it and it will bring you to this page. When it comes, you can just download it by clicking on this download button. And once you have your data set, you can save it, or you should save it in the working directory of your Jupyter notebook file. Okay. So once you are done with these setups, let's get started. So we'll be going through 8 steps. Okay. And the first one is to import the required or necessary libraries. So I'm just going to paste them right here. So the first one is NumPy. You import pandas, you import jump, you import train test plates, okay, standard scalar, support vector classifier, and you also import accuracy score, confusion matrix, and classification report. Okay, so these are the necessary libraries. So I'm just going to run it. And the next thing is we have to load our data. So I'm just going to use pd.read underscore csv. Okay, and we are going to pass in the name of our data set. So the data set has to be in the same directory as the file. So you just have to no okay, I don't want to open it. I just want to copy the name. So you have to copy the name and the extension. Okay, so iris.csv. And once you are done, you can just run it. And let's create some cell down here. So you can take a look at how our data set is. So for now, it has 1, 2, 3, 4, 5, 6 columns, right? So these columns, looking at them, ID won't be necessary. So we will drop this one, okay? And the next 4 columns will be our features, which is our input. And we want the model to predict the species. So the species column will be our label, right? So we can also check for the information, the data. So we have 150 entries from 0 to 149. And here are the columns. We have 6 columns, right? And each of them has their data type right here and the account. Okay. So for now, I think all of them are 150. So it means we don't have any missing data, right? Our data is clean. So we can go ahead and then split our data. Okay. So for now, let's split it into the features and labels. Okay. So I'm just going to say data dot drop. Okay. And here I'm just going to pass in the columns I want to drop. Okay. So for the features, we'll be using only these four. Okay. So which means species and then ID won't be part. So I'm just going to call species. Okay. And also ID column. Okay. And I'm just going to pass as this here, which is one. Okay. And our Y, which is our label, is going to be our species. So I'm just going to call it right here. So species. Okay. So with this, we can now run it. Oops, oops. I think there is a problem. Oh, sorry. It's supposed to be square brackets here. Oops, what is happening? Okay. Yeah. So when you run it, we can now take a look at our features. Okay. So we have features. You have sepal length, sepal with petal and petal with, right? So these are our features, and our label is the species. Okay. We have iris setosa, iris virginica, iris vesicular, right? And the next step is to now split these data into training and testing. Okay. So you have X train, X test. Okay. Oops. Underscore. Okay. We have Y train, Y test. Okay. And we are going to use our train test split function. So I'm just going to call this right here, and you have to pass in our x and our y, and also you have to pass in the test size. Okay, so no test size, not test, so test size, which you are going to use 20%. Okay, and you have to also pass in our random state. Okay. Mm, okay, so I'm going to run it. And what you are basically doing here is when we take our training data set or our features, okay, we want to split it into training and then testing. And we want 20% for testing, which means 80% for training. And when we take our label two, we want to split it into training and testing, okay. We want 20% for testing and 80% for training. So that is what this one means. We can take a look at them. So we can take a look at training data set, so which is 120, which means our testing will be, our test data set will be 30, right? So as you can see here, the entry is 30, and we can also take a look at this. So okay, so with our training label, we have entries of 120, right? Which means the test will also be 30. Okay. So with this, we can now move on to scaling our features, okay, to make sure they are within the same range. Okay. So that one I'm going to use the standard scaler. So I'll come here and I will create a variable called scaler. I'll call my standard scaler here. Okay, so down below I can now create a new variable to store my scaled values. Okay. So just, and I'm going to call the scalar dot fit transform. Okay, going to pass in my x string. I'll do same for my x test. Okay, so x test underscore scaled. I'm going to call my scalar dot fit transform. I'm going to pass my x test. Okay, so now when I run this, I can now take a look at my trained data set, which is now in the scaled version. So as you can see, it's different from the original one, right? So let's take a look at the original one, which is pandas data frame, right? But this time around, it's an array. Okay, so we've now also scaled it within a specific range. Okay, yeah. So now we've been able to scale our features. The next thing we will do is now initialize our model and also train it. Okay, so now I can go ahead and create, so let's say support vector machine underscore model. Okay, and I'm supposed to just copy this, then paste it right here. I'm going to pass in a couple of things. So the first one is going to be the kernel. Okay, oops, kernel, and I'm going to pass in the linear. Okay, so we have a couple of kernels. We have the poly, we have our BF. You can check them out. Okay, because our data is kind of linear, so I'm going to use the linear kernel. And let me now train my model. So support vector model underscore, or sorry, support vector model dot fit. Okay, so here I'm just going to call my scaled train value. Okay, so yes, and I'm going to paste it right here, and I'm also going to call my y train. Okay, and I'm going to run this. So we've been able to initialize our model and we've trained it with the data set. Okay, so the x train and then also the y train. Now we can make predictions. Okay, So we are going to call the CSV underscore model dot predict, okay, to make some predictions, and we are going to pass in our X test, okay. So the scaled version, we're going to paste it right here, and when you run it, you see now we are having all the outputs, okay, so the predicted values. And what I want to do is I want to get the values. So I'm just going to say y underscore pred for predict, okay. Let's say CMV, okay. Let me store it here so that we can use this to evaluate our model, okay. So now we've stored it here, and the next thing we'll do is evaluate our model. So we can say accuracy, and with the accuracy we can use the accuracy score we imported, right? So we can use this one. Let me just copy all these. Mm, Let me paste them here for a second. So we'll use this one, okay. And we are just going to pass in the actual value for our y, okay. So our actual labels, and then all the outputs, and then the predicted output of the label, okay. So which is y test, and the predicted one is this one. So I'm just going to copy that. So it's going to compare them, and based on that, it can get accuracy for us. We also have our conf metrics, okay, and that one also think the same thing. So I'm just going to confusion metrics, and that one too, we are supposed to pass in our actual labels, our actual outputs, and the predicted one, okay. And then our last one will be our report. So let's say reports. So classification reports, and that one too, we are supposed to do the same thing. Oops, copy and paste, okay. Down here we can just write some prints. So let's see accuracy, okay. And our accuracy is supposed to be this accuracy value. Let me copy that and paste it here, okay. Then the next one will be our metrics, okay. So our confusion metrics, okay. Mm, this is going to be copy this, okay. Let me paste it right here, and the last one will be our report, okay. So our classification report, okay, which is also okay. Let me see. All right. Oops, what's happening? And this one you have to just pass in our confusion classification report here. And now let's run it. Oops. I forgot a comma here, so I'm just going to bring it. When you run it, okay, so we have an accuracy of 0.9. We have our confusion matrix. We have our classification report here, okay. And as you can see, we have precision, recall, and F score here. So you can use that. So based on these precision and recall, you can calculate for your F score, right? Yeah. So the next thing we can do, the next step is to save our model, right? So I'm just going to say get a model name for it. So model, let's see, file name, and I'm going to name it. I'm going to save it. See underscore model, okay. And I'm going to call the dump, and I'm going to pass in my CM underscore model. So the model and also the file name, okay. So I'm just going to copy this and paste it right here. So as you can see now, let me now just bring some print statements here. Say model have saved successfully. Okay. And wow. So we've been able to save our model as well. So now later on when we want to use our model, we can just call the model, load the model and use it. So this is the model has been saved in our working directory, right? So these are the 8 steps in which you can use to build your classification model using your support vector machine algorithm, right? So you can just come to here and then change and use other kernels as well and see how it performs. Okay. Yeah. You can also change the size of the test size, the random state. Okay. So you can change these parameters and find out the one that works best for your algorithm. Okay. I hope you really enjoyed this video. If you did, kindly click on the subscribe button. If you haven't, share with friends, leave your comments in the comment section, and turn on your notification so that once we drop a video, you'll be the first person to enjoy it. In our next video, we are going to implement our model with naive Bayes algorithm. Okay, so watch out. See you next time.